In this lesson video, I'm going to go through the 6 properties of an ideal op-amp. Now remember, someone has designed these properties. We don't need to understand exactly how it all works. It's a black box, remember. But what we want to know is what these properties are that have been designed so that we can use them and we can understand them and we can apply them so that we know how the actual circuits will work. So let's dive in. Property number 1. Infinite open loop gain. Let me draw a simple circuit with a cell and a lamp. The lamp lights up because this is a closed loop. If I removed a wire, the light would not light up because this is an open loop. For the op-amp, closed loop means that the output is connected to the input. Open loop means it is not. The gain of the op-amp is how much it multiplies the input by to give an output. If the input is 2 volts and the output is 6 volts, the gain is 3. 2 times 3 equals 6. If the input is 2 volts and the output is minus 20 volts, the gain is minus 10. 2 times minus 10, minus 20. For an ideal op-amp, the open loop gain is infinity. Now, is that really possible? Of course not. But these are the properties of an ideal op-amp. A real op-amp will try to get as close as possible to this. That's what the engineers have to try to make. Now, standard real op-amps have an open loop gain of around 10,000. 10,000, multiply 1 volt by 10,000, you get 10,000. That's a pretty big multiplication, so we get close enough to infinity. So, property number 1 is infinite open loop voltage gain. Property number 2. Infinite input impedance. This is quite simple, although the word impedance may be new to you. Just think of impedance as resistance in an AC circuit. So, number 2 can be thought of as being infinite input resistance. This means that no electricity can flow into the op-amp. And that has got 2 important effects. First, since nothing flows from the main circuit to the op-amp will not affect the main circuit. This is great for a sensor. You don't really want your measuring device to change the thing that you are measuring. Second, with no current flowing in either input, the 2 inputs will always have the same potential. In fact, if you think of the op-amp as a device that is constantly working to keep these 2 potentials equal, it will explain a lot. We're not there yet though, I'll come back to that another time. Okay, so property number 2 was infinite input impedance. That leads nicely onto property number 3, 0 output impedance. Now we know what impedance is. This one's pretty obvious really. The output energy will come from the power supply. Having 0 output impedance simply means that we won't waste any energy. So property number 3, 0 output impedance. Property number 4, infinite bandwidth. Bandwidth. It's got many meanings. This is an annoying fact of life, so try to ignore what you think you know about bandwidth and learn this new meaning. Op-amps have gain. I mentioned that a real one is usually about 10,000 open loop gain. Ideally it would be infinite, but for bandwidth, ideally it should have exactly that value for any value of input frequency. Let me stress that. Input frequency. Remember, we are thinking about AC here, and AC can have any frequency. Think of amplifying a song, if that helps. All the sounds have different frequencies. If we amplify the song, we want all the sounds to increase in volume evenly. For an op-amp, its bandwidth is the range of frequencies for which gain is constant. On a graph, it looks like this. The flat region is the useful region for the op-amp. Ideally, the flat range would be infinitely wide and cover all frequencies. And that's what property number 4 means by infinite bandwidth. Property number 5, infinite slew rate. It's a new word, but it's quite simple. Although people do get the details wrong when they have to write it down. When the input changes, the output will change. That should be instant, but there could be a delay. Infinite slew rate simply means that the output will change immediately when the input changes. Lastly, property number 6, zero noise contribution. Another obvious one, we don't want the op-amp to add noise to the signal. If there is noise already there, then there's nothing we can do about that. The op-amp will just amplify the noise as well. But the op-amp should not add noise to the signal. That's property number 6. So there you go with 6 properties of an ideal op-amp. And these lead us to 2 key rules that help us explain all the other behavior of the op-amp in circuits. Rule number 1, the op-amp will work to make V plus equal V minus. The voltage at the non-inverting input will be equal to the voltage at the inverting input. Rule number 2, I plus equals I minus equals 0. The current going into the non-inverting input is equal to the current going into the inverting input, which equals 0. But if somehow V plus was bigger than V minus, then the output would be very big and positive. But basically the op-amp is going to work really hard to make sure that rule 1 and rule 2 are being followed at all times.